Hi, hello everyone. Last time we left off, with basically our sprite sheet loading, and this time we're actually going to work with rotations. But aside from that, there are some smaller issues which I wanted to address. The first one is here, you see some kind of white edges around our player ship, so let's figure that one out, and for that, I might just increase our player sprite to some width, and then height, I might say 300 for example. Then you can see this white edges here, and that has everything to do with alpha blending because I haven't set it properly. So if we go to our sprite renderer, for example, sorry, sprite pipeline here, you will find where we defined fragment state, you will see our blending, and for our color we're going to use source alpha. And why source alpha? So why move the source alpha? Well, first of all, we need to figure out this function. So let's say that we have our texture here. We have our texture, so let's call this texture source color, right? We get our source color, and then we multiply it by source vector. Source vector, sorry, this is f, and then we had our operation, which is add. So here we have our destination color, which is this background, or if there is a texture which was drawn before this one, it might be that as well if they're overlapping, but then we have our destination vector. And let's say our color was just pure white, but it wasn't fully white, it was also had source alpha component of 0.5. So here, previously we had 1, so we have, just for the simplicity, I'm going to say that our color is 1. So this is color. So these 3 components, I'm just, this for the simplicity sake because I don't want to write RGB every time. And we had a source vector of 1 previously, right? And then we had plus. Let's say our destination color here is gray. So let's say that it's maybe something like 0.5 for gray, right? This is destination color. So it's RGB of 0.5. Just writing 0.5 for simplicity. And then we had our destination vector, which here says 1 minus source alpha. So it was 1 minus source alpha here is 0.5. So if we do the math, we're going to get 1 here and then 0.25 here. So our resulting color is 125, which is basically a white, right? It will resolve it to white. So at the end, we're going to have something like 111 or 125, 125, 125. But obviously, you cannot go above to 55 for pixel. That's maximum. So it's going to be 1 at the end. So we get full white. But if we change this to source alpha, let's do just that. So we're going to do the same math with source alpha. So we had 1 for source color, then let's say source alpha. If you remember, it was 1, 1, 1, and then 0.5. So we had 0.5 here, and then destination was 0.5, right? For gray, 1 minus 0.5. This corresponds to here, right? 1 minus source alpha. So we get 0.5 here, and then here it's going to be 0.25. So we're not actually using full color like it happened last time. We're actually now calculating our colors correctly based on destination and source. And that's what was happening, right? It was full white. If I would just to refresh that. So it was full white because of that, right? We were just not calculating this color correctly. So we just need to use source alpha. So that's it. Second issue, as you can see, are these edges. And that's also an annoying issue. I was thinking it actually had to do with color blending, but it seems like it doesn't. So one way to fix it is, well, basically to go our texture and change our filtering to nearest. And now it's okay, but it is a bit jaggy here. But that's alright because we're actually going to use pixel perfect art in this game. So I'm not going to use scaling. If you want to use, you probably it's a bit weird. Maybe I should explain it. So one way to explain it is maybe enlarge this guy, so it's going to be easier to explain. It was here. So let's just say 600 across the whole screen. That's perfect. So just pay attention to these edges here right now. And if I was to change this texture filtering to linear, you can see it's kind of muted. And what's happening here, it's actually really simple. So when you have nearest filtering, I'm going to use this green and this magenta, for example. So let's do just that. Let's say that we have our pixel here. Let's say this small pixel here. And we have our green. Then also we have this magenta pixel. So when you're using nearest filtering, right now it's linear, but when you're using nearest, it will actually look at the distances here. Texture coordinate might be here, might be here, might be here. So if this pixel, if this pixel with this color is closer, it will pick this one. On the other hand, if green is closer, let's say here, so it will pick this one. But there is second option, and that's linear filtering. So it will take a look at both of these guys, right? And then instead of picking just one to fill this space, right? Imagine that we're filling this space here, and we picked the green one. But if we're using linear filtering, let's say we have this here, this here, and it cannot decide between those two pixels. What's it's going to do is it's actually going to linearly interpolate between those two. So it's going to do, it's kind of going to do this. It's going to use this color and then this color as well. So I cannot do this properly, but it's going to be a mixture of those two colors. So it's going to be a mixture of green, mixture of red, and that's why it has this, why it appears muted a bit, because it's actually mixing those colors. So with that said, we can just leave it to nearest. And if you want to do pixel perfect art, nearest is always the one that you want to use. If you're doing some sort of vector art, linear works better. For pixel perfect art, nearest. But I have this issue here, and with this, I'm going to show it again. So this was really annoying. It's annoying me. I don't know what it is. But you can see flickering here. And one way to fix it also is, because I think the issue is that art is overlapping a bit at some places, right? The edges and stuff. So you can also fix it if you want to use linear filtering. You can just maybe go to our content and then reduce this source rect maybe by some vector. That's going to work nice, and you can see there is no this flickering anymore. So that's one way to fix it, but I'm just going to use nearest filtering. So texture, nearest. All right, with that said, let's just move this. With that said, let's finally get to our rotations. So I just wanted to discuss those two things. So for rotations, we're actually going to refactor some stuff a bit. So it's just going to be a bit easier to work with rotations then. So let's just get to refactoring. So this here we had draw sprite source. So we had this here rect x, rect y, but I'm actually going to pass them to a vector. You're going to see why a bit later. It's just, I'm going to make life easier for myself. Let's just call it v0, and it's going to be of type vec2 create. Just make sure to import vec2, make sure that it's actually imported, and then we're going to have 4 of these guys, v1, v2, v3. And then here, instead of saying rect x, rect y, we're actually going to use those guys. So 0 is rect y. Okay, these are good suggestions. make sure to type this out, and then here, wherever we had top left, right, that's v0, that's vertex 1. So our top right was vertex 2. So this v1, we're using first component. So our vector 2 with GL matrix is actually an array of 2 components. So that's why I'm using these indexes 0 and 1. So we had v2, then here as well, and then finally v3. So please test it out. If everything works, it works on my side. That means it's all right. If I try to break it here, let's just try to break it to be sure that I'm working correctly. Yeah, it's broken. All right. So I got it correctly. So now to rotations. So for rotations, we're actually going to have just going to pass basically rotation here, and it's by default we're going to use 0. We're not going to use origin yet, maybe a bit later. So then if we have a rotation, let's say if rotation does not equal, no, actually, no, I need to do it after these guys. That's why I created them. So if we have some kind of rotation, we're going to perform it. So we can say vec2 rotate. Does it have rotate around point? I think it has. So it takes out vector. So this is going to be our v0. That's why I created it also. Then the vec 2.2 rotate. Actually, we're rotating this v0. The origin of rotation is actually going to be, let's just create origin as well. So by default, let's just say private rotation origin, create, and our rotation origin is actually going to be vec. So by default, we're going to rotate around basically this corner. So we can say vec2, sorry, we can say vec2 copy, and then we copy our v0 because we're rotating around this point, right, to our rotation origin, and then we can use this rotation origin, and then finally we just pass rotation. So we're going to rotate this point, then we're going to rotate v1, v2, and v3. So let's just change here, v1, v2, v3, 2, 3. That should actually already work if I just apply some rotation. Let's say here sorry, yeah, rotation equals 0. Just rotation, sorry, because it's outside of draw, it needs to be global. And then here we had our this thing here, we can just pass rotation, this thing here, and for our play. We also had color here, so we had undefined, and here undefined. So nothing happens, but let's just say this rotation plus equals 0.1, or maybe a bit slower. This is way too fast. But as you can see, it's rotating around that corner that I mentioned. So we can just move this to 100, 100. So exactly as I mentioned, we're rotating around this corner. And that's what I wanted to do. And this guy is rotating also around this corner. So let's actually handle rotation around any arbitrary corner for our texture. So how do we do that? Well, it's actually also easy. So let's just go to sprite renderer, and then we had rotation origin, draw sprite, not here, draw sprite with source, and then we're just going to say rotation origin is going to be of type vec2, and it's going to be set to null. And it's not working for some reason. Null is not assignable to vec2, so we can just say here vector null. Okay, that's all right. And then, so if we have rotation origin, we're actually going to use that instead of this v0. So we can say either this, if rotation origin is null. Let's actually just call it rotation anchor. So just that I don't mix it with this. So if rotation anchor is not defined, and then we're going to have else if it's defined. So we need to find our rotation origin now. So this rotation origin is 0, is going to be what exactly? Well, we're going to use v0, 0, plus rotation anchor, and then since I actually wanna use normalized coordinates, so for example, if we had a texture here, right? If we had this one, right? But if I say here I wanna go 1 in x, I want to end at this corner. If I say I also going to have 1 in y, I want to go to this corner. So normalize means 1, 0 gets here, 1, 1 gets here. This is 0, 1. This is 0, 0. And if I pass 0.5, 0.5, I want to be in the center. So that's what we're going to do. And how do we do it? Well, it's easy. We just multiply by draw rect, right? We had draw rect or rect, rather, then width. And then we do the same here, except we do it for height. And here we need to pass 1 and 1. Okay, we did that. And now in our main, I just wanna do small change. I wanna test that. So let's just say that we wanna move this texture around the center. So how could we do that? We have a rotation. We can say vec2 here, and then from values. I'll actually break this to new line from values, and let's say 0.5, 0.5. If I save it, you can see it's rotating around center point now. Let's just clear this. It's rotating around center point, which is perfect. If I pass 1, 1, it should rotate around lower right corner. 1, 1. It's rotating exactly where I said, around this corner. That's perfect. So this is how can you do rotations essentially. So let's just rotate this and rotate this as well. All right, perfect. So I was planning to explain rotations, but since this is already a bit long, and I have exactly the same video with WebGL. If you want to know more, I do recommend this wiki article. So basically, our rotation is defined exactly here. You can see it. It's just you use x, whatever x is, and then multiply it by cosine of whatever angle is, then minus 1 that sine. Well, essentially, you use rotation matrix, and if you go to maybe what is it called, vec2 GL matrix, maybe we can just take a look at the source code here. So you're going to see rotation. Not that one. No, maybe it's rotate. Perfect. And if we go to source code, you can exactly here see here that it's doing sine, cosine of radians or of our angle, to be precise. And then it does this. And what does this do? Well, it's exactly this rotation matrix, and that's how it kind of works. So if you want to know more, you can read the wiki article. But you can also check my WebGL series. It's going to be part 9 or 10. The video is called rotations, and then there I went a bit into the math of rotations. So if you want to know more, check there. Otherwise, if you like the video, please like, subscribe. There will be also link to Discord channel. If you have any additional questions or if you wanna something explained into a bit more details. Otherwise, hopefully you enjoyed this video. And the next time we're going to deal with inputs and probably we're going to add players and start some gameplay, but maybe even refactor stuff first because I don't like how I did this main, everything is bundled here. So I want to break that up a bit. So hopefully you enjoyed it and until next time.